Hi, welcome back everyone. So I haven't streamed for a while, like the last one was Friday, I guess, on my constraint solver, and I had several problems with it, but now everything works fine, I guess. I have to admit it was easier to work on it off stream. And the testing periods in between became a little bit easier. Just doing some stuff in between and not streaming felt a bit more natural. Anyway, as it is the scheduled Wednesday stream again, let's start with Project Euler problem number 41. All right, so you can start reading it on the right-hand side already. Let me just include our library for downloading it. All right, so I see new people joined the stream. Hello, everyone. Sorry for that. Yeah, we're starting with problem number 41 from Project Euler. So you didn't miss anything so far. Oh. So it's one of pan-digital ones again, and primes. So this is taking quite a while again, but yeah, let's read the problem description. We shall say that an n-digit number is pan-digital if it makes use of all the digits 1 to n exactly once. For example, 2143, so 2143 is a 4-digit pan-digital and is also prime. What is the largest n-digit pan-digital prime that exists? So let's use primes and maybe combinatorics. So one way of thinking about this is we iterate through all the pan-digital numbers of length 9, check whether they are prime, then go down to 8, then 7, then 6, and so on. But that might take a while. So we could do combinatorics. And we want to have the largest. So notations. So we probably want to go backwards. So this is 300,000. I don't know how long does it take to. Sorry, is prime. Oh, we should include benchmark tools. Pretty small, fast. Okay. Yeah, well, let's do the naive approach first. Maybe you can read it a little bit better now. We just care about the biggest. So for call it n, going from 9 to 1. Actually, we can go to 4 as we know that there is one, but let's keep it general. And then we have this, and we can have a look at digits again, as where the permutations will be not the number itself, but an array of numbers. So we can basically use this, and whoever was inverse digits, in the last stream, the okay, let's do it like this. If it's getting a little bit long, so maybe just to have better readability. So last time I made a pull request for Julia, because we don't need, I deleted them already, these square brackets. So the new docstring probably in version 1.6 of Julia will not have it, because this one is allocating and some also works with an iterator. So yeah, we have digits is number, should call it number, inverse digits of perm, the permutation, and is prime number, then return number. So I think I included it already. So length we get a different output than I expected. Oh, this should be, I didn't want to call it digits because it's a function, but yeah, I should change that. So we are moving backwards and backwards, and we found one with n equals to 7. Oh no. Let's okay, that is definitely different than I expected it to be. Let's use it for 3 maybe. Oh, and let's see. That seems to be correct. Oh, because we are not using digits, we don't have to reverse it here. So because digits reverses the order, so if we have inverse digits of 10, sorry, we get the reversed one here. So we need to change that. What is the best way to change this? Is basically having this should work. Okay. Not print that. Yes. That seems much better to me. And it's taking a while, so it's probably the correct solution. I mean, taking a while for ProjectEuler to verify it, whatever it does. And it felt relatively fast. It's only 5% problem, as most of the ones we have solved so far. But yeah, I know that permutations is quite slow in general, but it's less than a second. It's good for me to go to the next one. I'm in the mood of solving quite some problems today and not spend too much time on one of them. But what we should do is pen digital prime. Just fill in the test case. Coded triangle. All right. The nth term of the sequence of triangular numbers is given by, okay, the area of the triangle. Right? Oh, okay. So the first 10 triangle numbers. By converting each letter in a word to a number corresponding to its alphabetical position and adding these values, we form we have the words txt again. Okay. Sorry about that. For example, the word value for sky is 19 plus 11 plus 25, which is also the 10th triangle. Like also called triangular, right? Anyway, triangle number. And then we shall call the words a triangle word. Okay. Using words. 2000. How many are triangle? Okay. Let's download that one. And triangle words. Let's check that file. Okay, it's just one line separated by comma, and then we probably remove the. Oh, we can. Well, whatever. Reads line of that file. I think we don't need that anymore. And then we have words is words file 2 to end to get rid of the quotes. And then splits at that's, we should just get that. So include it. That looks all right. Just the last one looks off. Oh, didn't use n-1, right? Yeah. Okay. Do we need to so what we can do is if we have Tn equal then having it's basically n squared plus n. So that we have let's write it like this. And then we, what do we have? We have Tn. And that is also like this. And then we have plus minus, what is the, when I'm speaking English, I forget the German form of it. I think it's basically 1/2. Oh no, it's like this, plus minus square root of so b is 1, so I hope that's correct. Let's just check it very quickly. We have plus minus. By the way, can I do plus square root of 1/4 minus 2 times 55. Oh no, this is a plus. Oh man. And that's 11. Why is that 11? It should be 10, right? Why do I have this plus minus 1 error? But so if we have 1/2 times 10 times 11 is the 10th one. I'm a bit confused right now. What did I do wrong? Something stupid? I mean, it somehow works. I guess. Just confused. Let me think about that. So we have it really bugs me right now. What is wrong with me? Why do I solve it for? Anyway, please let me know if you find the error. So is triangle number I also need a function to check yeah. This will take x and oh, there's like a can do rounds, something like that, or just do this. Maybe it should be enough. Should always have plus 2 times x. Yeah, okay. Do that, and then for words in words, so need a number function words to number. Still have it open. They are all uppercase. 64. So can I do? Yes, right? Okay. Let's build up the number. Counter 0 is triangular number num. And then counter gets updated. Return the counter. And we have, you might be interested. Hi, Ival. I think I have some kind of error in this part. If you want to have a look, I'm off by 1 and I don't quite understand why at the moment. Okay, all right. Have a nice sleep. See you. Thanks for joining for a short time. Hope you're doing great. So we want to have int of letter minus 60. Oh no, I wanted to print the word woman. Oh, maybe print and the number 66. What is again the +2 +3 +4 +5 +6 +7 +8 +9 +10 +11 66? Okay, that seems correct. So 162. All right. D3. Do I always have this one? The number 1 billion. Okay, 1 billion something is a 0 to 9 pentagonal number. They love 10-digit numbers, right? It's so weird. Because it is made up of each of the digits here. Rather interesting substring divisibility property. D1 be the first digits. So we start with D2. I think I saw that in your stream, Eva, but you're probably already sleeping or on your way to bed. Kind of seems that I have seen that before. Anyway, I think it doesn't seem to be too hard. We need kind of primes, not really, but combinatorics. I don't have a better word for it. And we want the sum of all. Okay, anyway, we want to have for perm in permutations 0 to 9 this time. And we want to have it's so hot in here. We want to have the digits and probably want to have them reverse. That work? I always don't know whether reverse. Okay, that works. It doesn't work for strings, but that makes sense. Digits of digits of oh, seconds. That might be quite nice to use this one. So int 10. That way we have. Okay, I have to think about it, but it should be working. Because then we don't create a lot of new arrays every time. What? Am I stupid? Okay, it's nice for another point, but this we already have it in the correct order. Because permutations doesn't create numbers. Oh, that was stupid. Anyway, this is already a string, so this creates what we want. Here's a property. That means we want to have our inverse digits function again. And yeah, I copy it every time, which might be reasonable to have like a module for it, but now everything that happens is on your and my screen. So that's quite okay. Yeah, I'm not sure whether inverse digits is the right name now, but because it doesn't inverse the digits function anymore. It's more like array to number, which is a weird name. Anyway, so array to number of x. Let's call this also array. X sounds like so we have our primes. I don't know, up to 17. I think it's including 17. I check that every time, and it still is as it was before. So we want to have 2 equal 2 to 8. And then this is I, not u, and I plus 2. Let's call that n. If n is not equal to, so in general we assume it's true. and we break if it's false. So if n is not equal to basically the corresponding prime, then return false. We have our sum again, and if has subproperty of perm, then s plus equals to array to number of perm. We want to have the sum and return the sum. That doesn't seem correct. So has subproperty 14063. Well, that was already quite wrong. I think this is now correct. It is false. Okay. $406. That is correct. So this must be wrong. 2. Oh, what? No. Modulo. Forgot the question already. We want to check what it's divisible by. And it is. Oh man. What is it? Type max. Int 64. Okay. I think it's not an overflow. And it's taking a while, so that seems to be correct, and it is correct. It was actually faster this time. Subdiff. Let's go back to the next problem. And yeah, so for everybody who joined the stream recently, if you have any questions, just ask in the chat, and I hopefully don't miss it. But it seems like my setup is working fine, so I should not miss your questions. Oh, thanks for the follow, Adimator. Reminds me of the famous, I don't know, in the chess community, maybe famous Agatmato channel. But it's Adimato. Welcome. Not really. So they are not really competitive programs. It's more mathematical problems. So ProjectEuler is quite a old website with a lot of mathematical problems which are which can be solved or should be solved with a computer program, and people use it to learn a programming language, learn a bit of mathematics, just have fun. I don't know. I just wanted to solve the first 100 problems. I'm not damn smart. So they are getting really hard, but I'm still at the beginning. So Project Euler is kind of so I think they have 700 problems or stuff like that, and the first 100 are kind of free to share. So whenever you find a solution, you can write a blog post about it, or stream or whatever. I'm not sure about streaming on Twitch, as they get removed anyway after 7 days, but I also stream to YouTube. And it's just kind of, they don't want that the solutions for hard problems are out there and people can cheat easily and stuff like that. It's just against their spirit. But for the first 100 problems, they say it's like free to share, and it popularizes Project Euler, I suppose. So yeah, I think I started, I don't know, 2 months ago with problem number 1, and always stream for about 2 hours each Wednesday. So yeah, feel free to ask questions, provide solutions, and whatnot. And yeah, I solved it with Julia. I'm not sure whether you're into programming languages, whether you're into Julia, or how you found my channel. My first programming language was Perl. Probably I don't know, over 10 years ago I started with Perl, and then web development, PHP, JavaScript, then switched to Python for general programming, and then switched again about 2.5 years ago to Julia. And yeah, I like the Julia community, I like the language, and it's just fun to write, similar to Python, I guess. But it has like the feeling that you still can change the language, as it's quite young, and it's fast. So that's the main selling point for me, which was the main selling, my main gripe on Python. But I don't like C++ and those languages. They are not. I like prototyping a lot. Just started Python. Okay, yeah, I think it's a good first programming language to start with. Let me read through the problem. Feel free to just ask your questions. Pentagonal numbers are generated by the formula. Okay, that's similar to the one before. The first 10 pentagonal numbers are, so we had triangular numbers, 2 problems before. 1, 5, 12, 22, so on. And can be seen that P4 plus P7 equals P8. However, the difference is not pentagonal. Find the pair of pentagonal numbers Pj and Pk for which the sum and difference are pentagonal, and the difference is minimized. What is the value of D? Okay. So yeah, hi Animator. I've started programming before doing my my degree, or started. I've learned from my father. Like, I don't know, probably about 4 or 5 years before I had it the first time in school, and that was again 2 to 3 years, I guess, before starting my undergrad. So yeah, and I think it's good to start with C++ in general for people who want to really get into programming, because it's quite hard I think to switch back from a higher level language like Python to a lower level language like C++, because you think, oh, everything's easier with Python, and then you don't appreciate C++ as much. But yeah. So do we want to create a list of pentagonal numbers? Or do we want to compute whether a number is pentagonal? Probably the latter one. And the other question is, so we have, yeah, I think that's a good point. So that will return nothing at the moment, but true or false it should return. Then yeah, let's probably write that function first. So we have, I failed a little bit before with this one. So we have Pn equals to 3n squared minus n, and that's basically half. I think this is a little bit easier to read. That should be correct, I think. Then we have we just call it pentagonal P. And we have basically 0.5 divided by 2 times 1.5. Plus minus square root of wait, is that correct? Oh, I had a minus problem before. Now I get it. Where is my solution for this one? This one should be minus. Anyway, sorry for that. So this one is correct, but here it doesn't matter because it's squared in the end. So 0.5 divided by this again. I think we are here. Plus p divided by 1.5. And where's that? Probably want to have this function as well, which just checks whether it's discrete or not. I'm thinking about switching to Julia. Yeah, I think that's the main selling point. It depends though on what you want to program, I guess. If you need a lot of dependencies which exist in Python and you might not find them in Julia, it's might be a pain. But if everything that you need exists in Julia, go with Julia, I would say. And depends on whether you work with other people on the project and stuff like that. But yes. So this is n, and we have so Yeah, okay. I can do that as well. Should be plus again. And then we have what we had before. So 136 plus x, we call it p, check, divided by 1.5, and then return if it's an integer, basically. Yes, that seems to be correct. Okay, and then we have we might also want to have a list of pentagonal numbers. Just to have easy access to them. Pentagon diff or whatever, min pentagon diff. So the gap between always increases, but we have to think about that later. Let's create a function. Oh, are you coming here from my blog? Okay. Yeah. Hugo. Is that? Oh man, is that? What is the backend of Hugo? Is it PHP? Or what is it? Or is it Python? I don't know. But you will know. You can tell me. Numbers. It's like a list of integers, and for we call it n, so up to n, we create. Seems to be off. Go. Okay. Hugo. Oh, that makes sense. Then we have I times 3I minus 1. Where is, oh, okay. This from there. Return numbers. Go Hugo. It's like double go. Let's check whether that works. For 10 numbers, 1, 5, 12, 145. Exactly what they have there. Awesome stuff. And then we have basically we need a J and a K. So what we can do is I always stream now like on Wednesdays. Started an hour ago and will probably continue for an hour. I will not be here next week though. And sometimes I have streams in between. So as you've seen my blog, I'm sometimes working on my constraint solver, but is a little bit harder to stream on than Project Euler, I think. I also started a new project. Maybe so this is my new project. The goal is basically to do mathematical visualization and animations, such like it's just test cases at the moment, such like these with simple codes. If you know about Manum from 3 Blue 1 Brown, trying to do something like that in Julia. So maybe let's share the project with you guys. And let's get back to Project Euler. Yeah, it started Monday, I think. So if you want to contribute, it's the best time as nothing is fixed at the moment. And there's not too much code yet, so can easily add some codes, ask questions, provide documentation, write test cases and stuff like that if you are interested, or just watch it and see how it goes. So yeah, the idea was to use all right, see you later, Arimato. Yeah, I will stream for an hour, so if you have time you can come back, or see you another day, I suppose. Thanks for joining. So yeah, the question in general is now how to iterate over J and K such that we minimize D, so minimize the difference. So we have K is bigger than PK is bigger than PJ. But how do we? So we can, for example, if we check 1, 5, the difference is 4. If we check 1, 12, the difference is 11, but here it's only 7. So we should check this one before that one. And then 10, or this one also before that one. Oh man. So we can start with 1 and keep track of what is the next one and check whether a lower version is better than that. Or we can iterate over D directly and check whether we have it in there. But that might be harder to do. So basically we have next is, so this 1000 is, by the way, only kind of a guess and try whether we can find it. And if we find one, it's probably the smallest. So this is not a rigorous proof, as I'm currently not too sure how one should do that. Okay, maybe once. So for j or while true, j equals 1. And okay, I think I want to next, and do I want to save the difference maybe? So and then next of j is 2, and div of j equals pentagon num of j, that's minus pentagon of j. Which should give us 4 exactly. And current div is also 4. And yeah, we probably want to fill in the divs first. And this one is actually 2 to up plus 1. Collect. And filling the div. This is definitely one of the harder problems of today's stream, or the hardest problem of today's stream. Probably want to have that later. In 1 to up. Probably only that. And then we have div I, div I, div I, pentagon I. And check that out. That one is kind of wrong. So maybe we want to go that make more sense. Have something like this. Yeah, one more pentagon number. Length of this should be, okay, I think that should be correct. Now we have always smallest diff is minimum of diff. Oh, I want to have argmin. Can I get argmin and min at the same time? Somehow. Anyway, so this should give me 1, and then k equals to next of j, and next of j equals to well, plus equals to 1, and diff of j is then the following. Okay, and now what we want to do is difference delta maybe equals to probably what we want to return in the anyway. Just have it outside. What is the value of delta? Could use d, but I don't know why I use delta now. Well, use diff, but that's taken. Okay, so that is basically diff of j. At least it should be, as it's calculated that way. And now we want to have, but we don't. Oh yeah, so is pentagonal delta and is pentagonal j plus k. If that is the case, then print found j k delta and break out of the loop. Okay. That's it's kind of unfortunate, I think. Let's check whether we made a mistake or whether we need more numbers. Okay, I think we made it. Oh yeah, we should have this. So 5 and 7. What? It sounds so like a joke to me. 1, 2, 3, 4, 5. 35 and 70. Oh, no. This is not correct. This one is correct, but this one should be pentagon number. So PJ. Okay. Yeah. Okay, and then we probably want to just print that again. Okay. What is 517 and 536? And that is the difference. Okay, that seems to be correct to me. Do we just need more? Wow. This is really great. So as always, for everybody in the chats, if you have ideas or questions, feel free to ask. And yeah, also help me out if you have an idea what I'm doing wrong. Currently, I'm thinking at least that we often 1, 2, 3, 4 times. We have the same diff, and if the diff is not pentagonal, we can ignore the diff. Oh, we found one. That is quite a huge number. Okay, so at position 30,000. I don't like it when they say an error code. Okay. Okay. What is the value of t? Oh, wait a second. No, so what are we doing here? The pentagon number of the next minus, yeah, so this stays always the same. J, we don't change J afterwards. Seems to be correct. So what is going on here? Seems like we are increasing the, oh wait, no, this is bigger than that. Oh no. I am good. How are you? No, it's, you are good. Of course you're good. I thought you know that. You know that. All right. So we currently have a problem. And okay, so let me check. That is correct. Okay, it seems to be correct. And the diff is always increasing. So where am I wrong? Okay, I could also do asserts. Sum of is pentagonal of pentagon numbers, so broadcasting, equals up. What? Does broadcasting didn't work here? It does work. Oh, pentagon number. Num. Okay. So that checking also seems to be correct. This is so weird. Okay, let's do a check. So we have 4, 7. What about defining directly the difference in the sum? do you mean? You mean, so this is the difference and this is the sum, right? Sorry, I'm confused. Maybe you can clarify what you mean. 4, 7, 10, 11. Which one is 11? Oh, 1, 2. Yeah, 13. This seems to be all reasonable to me. So where is the error? Oh. But that's, I don't think that that is faster than building the lookup first. You mean then I don't need this upper bounds or something? But I still need the next and the diff, I think. I can increase that. And I think it's not faster to compute it than to look it up, I assume. But yeah, one could do that. Do you think that I made a mistake somewhere there so that this might fix the issue? Oh, wait a second. Oh. You mean solving it directly? That makes sense to me. Let me shortly something. Yeah, always. Sometimes I'm thinking using pen and paper would help, but I don't know how to stream that then with my current setup. But yeah, you might want to go for it. So I think I had 100,000 before. Super confused. Is it normal that they all end with so many zeros? Kind of confuses me at the moment. Oh, by the way, I should use form, but that's not changing anything. So 30,000 times. Okay, I think it makes sense, right? So n times 3 times n minus 1 by 2. Yeah, okay. So your idea is basically to get them together. Yeah, that makes sense. I'm just really confused why, as I don't understand why my approach isn't working at the moment. In general, let's say your approach is definitely better. Yeah, it's not, doesn't seem to be, so this is the highest one with 100,000 and type max is much bigger than that. So that shouldn't be the problem. Okay, so I am creating the difference with the next number minus the current one. That seems to be correct to me. And then I have where the minimum, the difference is minimized. Getting the next number. This also checks out. Do I have some problem here? Yes, I have, because they're not both pentagonal numbers. That is indeed a problem. So does I wait, which one is pentagonal. That one is okay. So that is already false. Okay. Maybe this one works. Are we up for another go? Okay, but yeah, in general, this takes a while. So if we use the formula, what can we get out of it? So we have maybe let's call it x, 3x minus 1 plus y plus 1, 2, 3. That is 3x squared minus x divided by 2 plus 3y squared. Damn. This is really a hard problem. But yeah. So basically we want to have the same form afterwards. Is there a possibility? I'm not that good at such things. Wait. So basically, we should have made that earlier, probably. 3 x squared plus 2 dx plus 2 d squared minus x minus d, and that divided by 2 plus that form. So let's get rid of the maybe that's right. Are you still trying to figure it out? What is it? IGN 3000, or is it an LGN? So we have, this is 6x squared minus 2x plus 6 dx, probably making horrible mistakes in between, plus d squared minus d. Okay. And we want to get to that form. Still computing stuff. Okay. Okay. I don't know how to write this down in a reasonable way. Because we need the 2 there as well. But we have kind of the same form as before. Oh, but we need the d in there, right? This is not, or like, we need some kind of x plus xd is what we want, right? Okay, back to the board. I think it's okay if we use this approach, as it's not like the hardest problem ever. Even the relatively naive solution should work. So, what is taking time and how can we speed things up? Because we now, I think we tried it up to 100,000. Is this part? This iterates over. Can we speed up? Let's have a look at 100. And where do we fail? We fail here, right? And this is, by the way, k plus 1. So if k plus 1 bigger than up, we break. Didn't know you were here. I wanted to kill you. Call you ill. Not kill ill. Hope you're doing great. So, what do we have? Can we do some interesting and reasonable benchmarks with this? Okay, so some things I wanted to check. Let's do something a little bit bigger. Maybe. So let's do 10,000. And that's taking a second. Okay. So let's do inbounds here. We should get out of the bounds. And maybe TS equals nanoseconds time TN equals that's minus TS print line. Where am I typing? So okay, argmin is what takes time. Perfect. And we have seen before oh yeah, okay, so that seems reasonable. So when do we go back? We only go back. Do we always go back to? No. I think I need some examples for maybe the first 20. So we can go back to 5, to 3. But we never go up more than what we had before. So we don't have to go up to the full 100,000 or whatever our up is. We can terminate earlier. Okay, let's write a special argmin early break of array. Last index, like up to that point we search, stop at. So basically type max int for I in 1 to last index. If array of I is that maybe a array, n an array, whatever. If n oh no, I wanted to only code points and I don't. Okay, maybe let's do if array I equals stop at, then return, and we want to return the I anyway. If array I is smaller than m, set m, and we've set m, we want to also set mi. So this is argmin early break of last index is biggest j1. If j, then biggest j updates, and we stop directly if this equals to delta plus 1. Okay, no, that's okay. No, this is not okay. Okay, that's faster, right? Oh man, this is so bad. I think it was 0.7 before. Yeah. Like speed of 3. I'm not sure whether it's like immediately obvious how to get the next argmin. So let's do maybe, let's do the 100,000, and let's do the 100,000 with the performance upgrade. Check whether the difference is much bigger. Because it's always, this is really the part that takes time. And I think it doesn't have to be. You haven't heard ProjectEuler for a long time. Yeah, it's an old website, right? Okay, maybe I shouldn't have checked. How about 30,000? Oh, that's already taken quite a lot of time. Okay, and the performance upgrades. A factor of 3. Okay. How do we get the next argmin? Yeah, and I think they are removing some and just constantly staying at 700, as far as I understand it correctly. Understood it correctly. What is the problem right now? Okay, so we have the next difference. How can we check what the next j is that we want to compute? Is there like a nice pattern for it? Maybe use human pattern matching. So 1, 2, 3, 1, 4, 5, 2, 6, going up to 3, going down, starting at the next 4, 5, then going down by 3, and before we went down by 2. Okay, doesn't seem like a pattern to me. So yeah, when you solve the first 175, you should be well equipped for this one. So the problem currently is, I don't know, I want to check basically what is the next j I want to check to minimize d. And currently I just always save the difference to the next one. But then I have to iterate over all the differences to check the minimum, which is taking like 100% of the time. Kind of 99.9 maybe. So what? There must be a good way. It's almost 2 hours. Normally I only stream for 2 hours. And I never stopped streaming like when I had an open problem. This is really annoying. Oh, can I? Oh, that's not working. I was thinking whether I can compute when each j is next. But I can't figure it out. Oh, can I just... Does it work to have a sorted diff? Is it easier to sort it than to find? That seems. Or maybe. Yeah, somehow it seems easier to sort the diff and insert it. KD, hello, welcome back to the stream. Doing Project Euler this time. So I'm currently having a problem. Because so I have to iterate over a list of differences all the time, and I think sorting them might be easier. I know if you're new to the stream, you probably don't know what I'm talking about. So yeah, the problem is I want to minimize the difference between pentagonal numbers, and so basically I start with the difference of 4, then check the difference of 7, then 10, then move back to this 11 difference, and always have to check when to move back. So what about sorted? Interesting problem. Yeah. Damn, what's wrong with my number? It's my keyboard. No, it's English. Okay. Sorted diff is and I have to keep track of permutations. This is really annoying. It's more like a sorted queue. What is it called? Priority queue. Is there something like a the lowest priority? Yeah, okay. Let's deal with it. What is it? Data structures, right? Hope it's correct. Okay. Let's do some checks. Priority. Do I need to? Okay. Probably want int and int. Okay. That's kt. So priority diff is a priority queue. So the priority is the value like and then maybe still saving the diff, even though I probably don't need it. Oh yeah, by the way. So NQ, PQ, 1, 2. The lowest priority key and okay. Can I check the priority somehow? Well, it's okay. We have priority. I hope this works in the end. The key is I and the diff, the priority is the difference. And then we basically DQ the priority. I understood the question. Good job. So, and then we want to have, I hope I understood it as well and not making total bullshit. And here we want to have, so our J gets a new priority, which is this. Okay, time for some fun. Okay, that seems to work fine. Yeah, sure. Tell me how you would solve it. Okay, that seems to be fast. That's okay. But yeah, I'm probably doing something weirdly wrong and I'm getting into high numbers. And yeah, it's still quite slow. So I'm basically trying, let's go back to the problem. I'm basically trying to get to the next difference all the time. So I found maybe the answer now. So I've started with difference 4, then do difference 7 between these two, difference 10 between these two, and oh, you mean whether it's correct? Yeah, I enter. This seems to be wrong, or maybe not. Does it checking now? No. Now it's checking. Okay, it's the correct answer, but it took 30 seconds. Would you solve it analytically? Or how would you go with it? Now you don't spoil. I solved it. I solved it in a slow way, but I solved it. Okay, so please enlighten us, and then I will finish the stream. Sure. You're thinking quiet, but I can read it out loud. Or maybe you're actually thinking out loud and I just can't hear it. Well, you keep typing. Still searching for a pattern. Just removing some stuff that I don't need anymore. To get some actual timing. Or maybe this case. Forty seconds. Yeah. So maybe reading it out loud. For Pn, you can generate Pn minus 1 and so on until Pn minus m. By the way, what is m? And check each for each of them whether it satisfies the problem requirements. Yes. And then doing it. But how do you know? Oh, because then the difference is too big. Okay. Okay, and when there is no way of getting smaller than the smallest difference you have, you're done. Right? The question is... Oh yeah, okay. So you think It does make sense, I think, yeah. So this removes the problem of searching for the next smallest difference, and kind of the sacrifice of it is that you might compute a little bit more to be sure that it is the smallest difference, right? But yeah, it makes sense to me. I think I always increase the diff such that so I basically find by sorting what the smallest difference is, and if I found something, then I know that it is the smallest one, because all afterwards will be bigger. I basically increase diff or increase d, and in your way, because they're getting bigger all the time, I think your algorithm works fine, and you just have to make sure, so you basically increase the n every time, and if you found something, you increase it, subtract pn minus 1, and then if that is bigger than the difference in your algorithm, you will never find something smaller, so you can stop and return the smallest. I think that makes sense. And is probably faster than my solution, because it removes the sorting requirement, and everything that's part of your algorithm is quite fast, like computing if it's pentagonal or not. So yeah, it makes sense to me. Thanks for spoiling it. No, thanks for mentioning your ideas. So I will not be streaming next Wednesday. I will be traveling then. So I might stream on either my new projects for anyone. So this is my new project of animating some weird stuff in Julia. So the goal is mathematical visualization done easily in Julia. Just started with it on Monday, so I might stream on it, working with the setup prince, aka Jacob Zelko, on it. He streams as well. I think he streamed when I streamed. We started simultaneously, kind of. I think he's not streaming anymore, but I don't know. Maybe I can figure it out, and then he is still streaming. All right. Anyway, I will finish with my sponsors. So normally I blog on this website about my constraint solver and some other projects, probably also the new visualization projects in the future. And I have a Patreon page and huge support from 10 people at the moment. And the one you can see on your screen right now are the ones that pay $4 or more per month. And they get well, they are mentioned in every blog and live stream they support. And everyone who supports me with at least $1 per month gets my blog post 2 days earlier than anybody else. Live streams are live. Thanks for joining, everyone, and see you next time. So follow me, subscribe if you liked it, and then see each other in the next stream. And I try to rate Jacob now. I hope that worked. Let's see. Anyway, thanks for joining, and thanks to my anonymous friend for the intro music as well.